All right, we're going to talk about similar figures. So remember last time we talked about congruent figures, and congruent figures meant that they were the same shape and the same size. So that means their line segments, their corresponding line segments were the same, their corresponding angles were the same. Well, when we talk about something being similar, that means we've either like taken something, put it in a copier and made it, enlarged it or reduced it, made it bigger or smaller. So those angles inside there are still going to be the same because it's the same shape, but the line segments of those two shapes are not going to be the same anymore because they're going to be different sizes, but they are just the same shape. So remember when we used congruent, we had the equal sign with the little squiggly thing over it because that meant everything about them was also equal. But on similar figures, we just use the squiggly line. And so that means that they're just similar, but they're not everything about them is equal. So, for example, if you have a big triangle, and then we have a small triangle, and I told you that these two were similar to each other. Well, you can see the line segments are not going to be the same, but their angles inside there would be the same. So this angle would be the same as this angle. And whatever this angle is, it would be the same as this angle. And whatever this one was, that angle could be the same as this one. So those would be those numbers would be the same, but obviously the line lengths wouldn't. And so we also say if something is similar, then their line segments would be proportionally the same. And so do we remember how to solve a proportion? So let's just look at that real quick and have just a little review on how to solve a proportion. Let's just say if we would say something like 10 is to 5 as something is to 20. And we would do that cross multiplication on there. So hopefully we sort of remember how to do that. So we would say 5 times x is 5x, and that's equal to this 10 times 20, which would be 200. And then in order to solve that, you divide both sides by the 5. So x would be equal to 40. And so that proportion then would be 10 is to 5 as 40 is to 20. It's like reducing or enlarging those fractions. The proportion there is still the same. It's you just made something bigger or smaller, whichever the case may be. Okay, so being said that a proportions are the same, then let's look at two triangles. And so if I have a triangle, and we'll label it ABC, and I say this is 5 and this is 10, and then I have a bigger triangle over here, and we're going to label that 9. And this one we don't know, and so let's label it D, E, F. So you may be told that here triangle A, B, C is similar to triangle D, E, F. Well, if once you're told that, then you know, okay, that line segment AB has got to be similar to DE, so we can set up a proportion. So 5, line segment AB, is similar to line segment DE. 9, it's got to have the same proportion on the other sides. So then AC, 10, is proportion to DF, which is our X. And so we can set up all these different proportions, and we could say, so in this case, just so you can see that, AB was similar to DE, which is similar to AC, over DF. And can you name the last one then that should be? So BC would be proportionally the same to EF, and all those proportions should be the exact same. So you can cross multiply here to solve for this, and that gives us 5x is equal to 90. Divide both sides by 5, so x would be equal to 18, and then that tells us that line segment DF is equal to 18. And so you can look at some of those problems and do that cross multiplication. Again, use that hint that if you're told that these figures are similar to each other, then that order does matter. So you can always try to find that, which ones should be congruent to each other. And then just be very careful. Sometimes I'll even write over here, I put the small one on the top and the big one on the bottom, and so that helps me make sure I've set up my proportions correctly when I'm solving for those, to not get them mixed up and solve. So the small one would go on the top, the big one would go on the bottom, or as long as you're consistent with that, you should come up with the same answers.